Hi
Hi,
there.
Rachel.
How are you?
Hi. So glad to have you here. Thank you. I'm super interested about the talk you are giving, but more on that later. Maybe you just tell us a few quick sentences about who you are and what you do.
Well,
Tell
I'm
us our audience.
Rachel Appel, and I work at JetBrains as a developer advocate. JetBrains makes a bunch of developer IDEs and tools, such as IntelliJ on the Java side, Rider
Which
for
I love.
.NET. Yeah, well-loved
Yeah.
tools. Before that, I was an independent consultant, and I also had worked at Microsoft for a while. So I've been saying in the other sessions, I'm kind of like the odd bird here who's the .NET person at the Java conference. So, yeah. So Azure Functions, Nikolai was interested in having a session on that. And I said, well, my talk is normally in C#, but you know what? You can actually write Azure Functions in Java. So I did the session in Java.
Yeah. Yeah, so I'm super excited to have you here and a real developer from JetBrains. I love your tools. I've been using them for 10 years plus now, but of course, mostly the Java related tools, so IntelliJ. And how does it feel? Did you always were in the Microsoft environment, or you just like went over? I've done project myself in C#, so I know that it's like comparable some things and
well, it depends on how far you go back. I've been in software development for about 30 years now. So you go far enough back, and we didn't have .NET. So before .NET, there was some Microsoft things that I did, but I also did stuff like COBOL and the Borland tools, and even like Clipper and DBase and those kind of things. So those are not Microsoft, but they're not relevant anymore.
MS Access databases still are.
Oh, those things. Yeah, I done enough of those.
Yeah, lots of small companies running off those.
Even the big ones.
Even the big ones, yeah.
Yeah.
So cool. So you always, or you came to the Microsoft world, and I think Microsoft right now is pretty much open source, or most of the development technologies, they open source them themselves. I think there are more Linux machines on Azure running right now than Windows servers.
Yeah, I never thought I would see the day. But yeah, Microsoft has embraced a lot of things that are very unexpected.
I think they switched all their development over to Git and from their proprietary versioning control systems. So they're actually quite happy with this. Yeah. Cool. Okay. And how long have you been using Azure and the related technologies with it? Like right from the start, or you came?
Yeah, basically, it depends on what level of Azure you're talking about.
Yeah.
Certain things, you know, there's so much to it, but cloud apps and anything related to .NET development kind of from the start. But there are some of the things that I just hadn't gotten into with the on the database side and stuff like that, or some of the other admin type things. It is a pretty huge platform full of stuff. Or like AI and machine learning, just haven't gotten into that yet. Sounds cool though, but
it is a giant ecosystem. And did you is Azure your first cloud service, or did you start with AWS or Google Cloud and then move to Azure? Or
no, it'd be Azure basically. That's it.
Yeah. Because like when I think of Azure Functions, I tend to think of it as like Lambda functions. So Amazon calls it Lambda functions, but just the Azure version of it.
That's kind of it. I mean, they are very comparable to AWS Lambdas.
Cool, cool. So, and this talk is also very high level relevant for me, because in my current client project, we are doing data normalization on the Azure cloud, and we're thinking about using Azure Functions for it. But I just, tomorrow we'll have a talk about this. So I don't know about the cost when we're using this for terabytes of data, if there is a more economic way of doing it, or if Azure Functions might be the right tool. I'm eager to learn, so.
Yeah, so for the costs, somebody or even myself could probably give 30 minutes worth of a talk just on how to structure pricing. So you should be able to find something to do what you want that's economical. It depends on what your code looks like, which is
okay.
what would depend how much it costs with an Azure function. So the easy thing to remember is you are only billed for an Azure function when that function is running. If you pick this pricing plan called the compute plan. Outside of that, you could have flat rates and things, but usually the compute is best, and it only charges you when it's running. So unless your code is doing loops and lagging when it shouldn't and isn't well written, it should process fairly economically. Now, of course, large data and time is going to cost more, obviously, just because of that.
But it's funny how development transitioned, right? So in the past, it was like, okay, we stored it in the database and then we copy it over again. And now it's like, oh, we just store it once and don't use too much process power since we are built from this and this. So really, when building an application, cost is one of the things you consider right from the start, or at least in my experience when I'm
generally in the cloud. Because of that billing statement.
Yes.
Yeah.
But it's actually, I think actually most of the services are actually fairly cheap, or a lot cheaper if you compare it with your on-premise data center, all costs combined, personnel and stuff.
Yeah, I was going to say, if you think about it, you would still do these things in your on-site environment, except that you kind of just wouldn't care. There would be some employee you would rely on to help get these things done, and you would just be eating up their time, which also cost money. But because you look at it differently as an employee's payroll as opposed to paying for a service, people tend to think like, oh, well, it costs so much more. Well, the costs really have just shifted somewhere else, right? You'd also have to buy the equipment and all that. So
now it's visible. So if Bill is always there and Bill's paid and it's been here for 10 years, so his time it's not running up on my project schedule. So so I think that's actually quite cool. So you get a lot more transparency, and you see that all applications that you can just shut off, and they are shut off because there is a monthly recurrent payment for them. So it's just different, and it's an exciting time, an exciting way to go. Cool. Yeah. Do you like it at JetBrains?
Oh, I love it there. It's great. Yeah. People are nice, and they work on really cool stuff. So,
yeah, they also like a couple of years ago, they spread out their whole ecosystem, or it was long years. It was only IntelliJ and U-Track on stuff like this, and then they took the shell, and every plugin now is their own project.
And we have basically all the main languages that you would want covered. So we have, Goland and Sea Lion, RubyMine. We have all these different IDEs.
Yeah, and Kotlin, their own language.
Kotlin, a whole language.
Yeah. Did you ever work with Kotlin? I've heard good thing about it. I wanted to try it, but I've never actually taken the time.
So I haven't done anything production or productive or specific with it. Just playing around and going, oh, this looks cool. Oh, how does this relate back to other languages? Just kind of tinkering, but nothing important or special with it. So,
okay, cool. And now we're learning something about building awesome Azure Function apps. And I think thank you very much for giving the talk. I want to make a disclosure here. It's pre-recorded, so we skip some problems which might occur when we're doing this live. So just let me see that I can put on the talk.
Well, also before you started, then sometime in the talk,
yes,
I referenced platform as a service, except I said platform as a system. So just being old and the wrong word comes out of your mouth.
So you see the YouTube videos where there's a giant text written over it. I meant da-da-da-da-da. I said them quite a couple of times. But I know if you record and you're doing this in this kind of situation, you might miss one word. Yeah, happens to me also. But thank you very much.
Hi, and welcome to Build Awesome AF Apps. This is Rachel Appel. Let's start with first, what is an Azure function? An Azure function is a little piece of code, literally a function, just like you would write in any language. Just a tiny block of code that often has some inputs, often returns a value, and it does a single thing. But we take this little block of code and we add an event called a trigger and data, and then when we put them together, we get an Azure function. In a way, an Azure function is just a little function that you can deploy out to the cloud. You just kind of throw the function out there in the cloud and have it run. So it's literally a function, just that single unit of work. Stored in Azure, obviously, it's an Azure function. A trigger is that event that causes it to run, and it does have inputs and outputs. These inputs and outputs are often not the same exact kind of input or output that you might expect from any old function in any old language. These inputs and outputs are bound with what are called bindings to certain assets in Azure. And you can then have an input perhaps from an HTTP endpoint or a queue or the service bus. And you can take that and process that input and then send output maybe to another message queue or Azure Table Storage or the event grid or one of the Excel services. So there's so many things that you could take with one little function and bind it to and receive data from and send data to. So Azure Functions are great connectors. Some of our real-world usage scenarios for functions. Vehicle and package tracking. Everybody's doing this. Every time you scan a package, you can have that device transmit. If it's Wi-Fi enabled, it could just transmit, or maybe a phone even to transmit that data to an Azure function, HTTP endpoint. That endpoint can receive that data and that scan and then send it off to the correct processing software. Data cleanup and ETL, right? Edit, transform, load. So that's something that's happening in tons of companies everywhere. A function that just runs maybe on a timer. So the trigger would be a timer, and it runs nightly, weekly, monthly, stuff like payroll, or the classic, taking data from one system and processing it, running a few rules on it, and then sending it over to another system. Of course, small endpoints for miscellaneous jobs. You might accept an HTTP endpoint for something, do a little processing, and kick out a result. A lot of IoT solutions, hooking up all kind of widgets and gadgets to Azure Functions. In Washington, D.C., in the area, they were using a IoT solution where they were placing sensors on the streets to do snow depth monitoring. So whenever it snows, then they have these sensors out, and as the snow falls, it can sensor the weight of the snow and give an idea of how bad the roads are for traffic control. Same or very similar kind of concept, football equipment monitoring. Some of the sports ball folks over in the US have been taking IoT sensors, putting them in players' uniforms and in their sportswear, and then as they're running into each other, and when I say football, again, this would be American football, not the actual football, and they're taking the smashing together and measuring that to see exactly how much pain and suffering they're causing to each other for the sport. Internet traffic reports. I have a friend who did a project for a client that was really huge, and this client actually served other clients with big names like McDonald's and like all kind of places that are Ford and BMW and stuff like that, big companies like that, and insurance companies, and they sold a internet traffic report system. So this way, when you're at work, you log on and it watches what you're doing to get stats, seeing if you're, sneaking around on Facebook instead of working or that sort of thing. Well, every time they would do something, all of the logging went through Azure Functions. So tons and tons of usage scenarios for it, from tiny, tiny things to very, very large things. So something that comes up often is, well, okay, so you have these function apps and you keep saying HTTP endpoint. So what's the deal between a function app and maybe just an API, right? Because it doesn't appear that there's any front end, and there's not. Any front end that you might have is going to be built by you or by somebody else. So it might be React or Vue.js, a nice little JavaScript front end that sends the data to the endpoint in HTTP, or something very simple like that, or even a Windows application. Whatever the deal is, the front end is not part of Azure Functions. It just simply is some front end that can send off an HTTP request, right? Get or post. So function apps are generally non-visual. API apps are also non-visual. Works in that same way, in that you'd probably have like Vue or React or some JavaScript front end or something else sending the requests in and pulling requests out. So for function apps, we would do things like data processing, like I said. Also, if you're moving to a serverless or microservice type architecture, this works well here. And serverless, of course, meaning there is a server. Yeah, joke's on us. There's a server. It's just that that server is somewhere else and you don't have to deal with it, which I'm all about that. Years and years ago, I had to do a little bit of network admin, and we are talking NT4 days. So that was way back, and that was enough. So I prefer to do software development, not manage the system and do system admin stuff. And you know how it goes. Developers and admins sometimes butt heads a little. So if you put stuff in the cloud, it's a nice way for you to just be able to deploy your apps to a safe location and not have to be giving the admin a hard time or having them bother you about things either. And you can work nicely together, a little more smooth because of the technology. Function apps also perform executable routines, right? Often stuff that runs on a timer. A lot of these things, the timer-based apps, right? Every company has this, an app that needs to happen nightly, weekly, monthly, quarterly, etc. What we could do is we could use that timer trigger that's in Azure Functions to go ahead and have it just blast off an executable routine and maybe connect your CRM system with your ERP system, or maybe even CRM again with your homegrown system. And I had some clients that were doing that as well. Function apps also, it's just an endpoint if you do HTTP. Maybe you're not. Maybe you're doing a timer, or maybe what you're doing is setting up a message queue, and anything that puts data in that message queue, maybe some other function or some other software that's custom or whatever, puts data in that message queue, your function app then would be triggered by the insertion of the data into the queue. So that's something that makes working with queues a lot easier as well, because we don't have to worry about monitoring them and doing all of the legwork around that. So it doesn't have to be RESTful, right? It could just be an endpoint. And it's great for stuff like integration, especially if those kind of systems that run on the cloud. API apps generally is about retrieving data, forms over data, a very classic type of program. In many, many companies, almost everywhere actually, you're going to have those CRUD operations, right? Create, retrieve, update, and delete. And with those, you're going to have some kind of a form, right? And the front end doesn't matter what you use, right? Maybe it's JavaScript, maybe it's ASP.NET, or Java server pages or something like that. So you might have some front end, and then that talks to the API, and it's usually forms over data. So it's just grabbing data out of the database, presenting it to the user makes changes, and then the data goes back in after it's run through some business logic. And that's a pretty standard setup. So that's your API app or standard app setup. Right? Often we don't do software integration with APIs. You can, I've seen it happen, but generally that's not always the best solution. But function apps is really great for that scenario in particular. Let's dig a little deeper here. Some of the features and benefits first. Of course, again, is more software to help us focus on solving business problems rather than having to do some of that structure around it. For example, if I do have a batch process that has to run nightly, somebody actually has to write the code for the timer to happen. And then once the timer happens, to kick off that job. And then after the job runs, to make sure that the job actually completed, maybe even check a log to make sure there's no errors, maybe even email that log or something like that, so that somebody can verify that it's actually done. So all that kind of stuff is done for you once you're talking about Azure and the cloud. So we don't have any worries about infrastructure. Deployment. You do actually deploy. I know the slide says no deployment, but really you actually can just develop locally and then just push it to the cloud without full deployment regalia and full deployment ritual that you might have. Although if Azure Functions are part of a large project, you can easily incorporate this into your CI and CD process. That's fine as well. Another thing you could do up until recently, and you could still do some of this, you can actually deploy, or not deploy, sorry, but you could develop in the Azure portal itself, which is just a web page for you to go and manage all of your Azure assets. And that's really what I mean by no deployment. Really for the developer, you want to develop with your favorite tool and then push up to the cloud. It's lightweight and of course cross-platform because anything can get to that function if it's exposed via HTTP. So for serverless, it's about running code and not computers. So again, we have that great benefit of not having to have that administrative level in there. It's part of serverless computing, so it's a platform as a system, so it's just not your server again. Tends to be stateless, so we don't want to be carrying state all over. If we need to, we can accept some data, put it somewhere such as a queue, and we can pick that up later in another function. And that's one way we could pass state together rather than holding up memory on a server somewhere or on a serverless cloud somewhere. The things about the architectures for functions, it's great with complicated architectures. If you have all kinds of moving parts and working parts and things that need to go together, sure, this is a much easier way to manage all of your assets in one place. Another great thing for functions and serverless is sporadic workloads. For example, an event like this one that you are attending, this only happens once a year. And ticket sales might happen, say, up to 3 months in advance of the event. And the rest of the 9 months, what is the software doing? It's just sitting there. All right, so nobody wants to, no admin, no developer, nobody wants to be patching the server, being worried about security updates, having to, possibly make software updates because of the OS updates and having to keep everything logged in and change the password and do all those kind of admin things for 9 months when you're not even going to use the software, as well as the costs involved. So with something like this, you could just push out your function and then say, I'm done, I used it, turn it off for 9 months, and then turn it back on. And as the workload increases and the number of users amplify, it just automatically scales. So you don't have to deal with any of that stuff. And I like that. I like not having to dealing with those things. Also, for serverless computing, we tend to perform actions, do stuff, link stuff, connect systems and programs, more so than just getting data, returning data. Right? And there, it's always event-driven, and we'll see that with those triggers. So, as I've been saying here, it's stateless, things that are outside of a traditional project structure, too complicated or too simple. Right? Sporadic workloads, less human involvement, and lots of services and integrations. These are all great scenarios for the serverless apps. So let's take a look at programming functions. What you need as a Java developer, and I come from .NET, so I'm used to doing Azure Functions in C#. So I did have to go and look some of this stuff up. You need your Azure account with an active subscription. You do need the Java Developer Kit version 8. You need Maven 3 or above. I guess you don't need IntelliJ, but it's more than helpful because we have this Azure Toolkit for IntelliJ, which makes all of this possible. So it just integrates nicely with the tool. So of course you definitely want that. And of course, working for JetBrains, we're the folks that make IntelliJ. So it's an awesome IDE for Java. So you need those things. Now, once you do that, to look at a trigger, that single unit of work, or a function, that single unit of work, starts with a trigger, and an event happens. Say somebody goes to an endpoint. That causes this block of code to run. When it does, it can then accept some input that you define. Runs, and then it does the output. All right, so triggers can cause functions to run. Generally, there's just one trigger per function, and it will have one input binding attached to it. There's various triggers that you can use. Request, timer, Cosmos DB, queue storage, graph events, event hubs, blob storage, so some great stuff for the triggers. After triggers comes bindings, and they're the way to do inputs and outputs. So we have those two directions, in, out, and of course in, out, which is like a ref or an output variable in C# even. So these allow you to access objects outside of the function, all of those things that we talked about. So queues and tables, even Twilio, to be able to send SMS or email or something like that. A function can have multiple input and outputs, which is awesome because some languages don't let you do that, right? Multiple outputs. Could be Azure services you connect to for inputs and outputs, or third-party systems. And I have a nice little bit.ly link that gives a list of all of the bindings that are input and output for you to use. Here's a quick slide showing some of them. A lot of the cool Microsoft Graph stuff is the new hot technology, but also you get SignalR, table storage, blob storage, all of these for input. And then output you have even more, such as Event Grid, the IoT Hub, all of the graph stuff, mobile apps, Twilio stuff. So of course you would email or SMS as an output. That's not necessarily something you would input. But a lot of these cool things with the output bindings. Now let's go take a look that we now have triggers, input and output bindings, and we have kind of an idea about them. Let's look at the code really quick here. So I'll go to IntelliJ and I'll quickly create a new project and we'll just see how this works. If I want to do this in Java, if I'm using IntelliJ, because I have the Azure Toolkit, here I have Azure Functions. I'll quick grab that HTTP trigger and I'll do next. And here I'll just pick, I'll leave everything default for now. And the project name, Azure Function Examples, I'll just change that to my Azure Function. Click Finish and give it a second, and I'll start scrolling here. And you can see if I work my way down into the code, I have a class, and because I picked out HTTP trigger as that trigger that starts the function, then we're good. Okay. Now with IntelliJ and Windows, it's asking me about Windows Defender, so I'll click Fix and just tell it to go ahead and do that. Okay. Now with my HTTP trigger, let's take a look at this code, and I'll split it into multiple lines just so we can get a better idea of what's happening here on the screen. Format it just a little bit nicely here. So you see there is a class called HTTP trigger. In it, I have a function that has an attribute attached with the function name. This is the name as it appears in Azure Functions. Right? Then I have my HTTP response message, is what the return is, and it's just called run. So you can call all of your functions run, but the function name as it's identified in Azure Functions is what's marked up in that attribute. Then inside of here, we have another attribute describing the HTTP trigger. And here's the name of the trigger itself, not just the function, but the trigger. The methods, get and post, auth level, for here anonymous, but there's also by the function, or if you have multiple functions that you package together, then you can have a whole function app. Right, so that's fine. The HTTP request message, so that's the actual payload of the request. And this piece that is marked final, this argument, and it's the context, which is a type of execution context. And what that does is that's just passed in automatically for you, so you can get to things like logging. And you see in the very next line, there's a quick little sample of context .getlogger.info. So it just does a log. Then here I have my a little couple of strings. One that gets the query parameter, and it's called name, and then one that gets the request body. All right, and then it does a null check, and then request creates a response builder, either a bad request if you did not supply a piece of data for the input, a query string. But if you did, then it just spits back out hello, whatever. Now, I could add to this method, instead of just HTTP trigger, I could put at HTTP queue, or actually queue names, something like that, or Azure table. I could pick any of those outputs, and then I could tell it, don't just spit this out as an HTTP request, but send this to a queue, send it to Twilio, send it to something else. All right, so I could do all of that. We really only have time here just to go over this basic way of being able to write this function. But it's all documented at docs.microsoft.com, and it's right under Azure Functions, and there's a whole section on Java, and particularly using IntelliJ to do that. Now, if I want to test this, I can then do a run, and I could just here click my little run button. And once I click run, I will see that it actually does run, and I'll see some output, and it might take it a minute. And you'll see that it starts at port 771, and then you can just change that around, and you'll see some output. You'll see the functions logo here, a bunch of the Java runtime verbatim, and some other stuff. And then here it spits out where the trigger lives, that you're in the development environment here, and some of the other stuff going on. So there's multiple things I could do now to test this. I could fire up curl, as they show here in the comments. But another thing you could do that's quite nice is if you're using IntelliJ, I could come in here and do a new HTTP request, and I'll just call it requests. And this is just a .http file. It's just a text file, and I'll paste in a command. And all you're doing is saying like get or post, and then pointing toward the endpoint that you want, and then what you want, like caching, what do you accept, and do you want headers or anything else. So in this case, I will add the name. Okay, so once I have that, I can now run this, and it's going to point to here, right, localhost. And if I take a look at the bottom, I could see it did actually print that out. If I take this off, this query string, and I go ahead and I run it again, you're going to see here that it does give me back a bad request, just like the function said it would. Right, so I can test it out pretty easily here with HTTP request. If you have a favorite tool like Postman, or if you just want to crank up a browser and do your F12 tools, like that works fine too. Really anything that can send data to an HTTP endpoint and look at the back and forth works. All right, so that's all good. All right, so there I have that. Okay, works. Once I'm ready, I could show you the quick deployment here. What you could do is go all the way down to the bottom on a right click, go to Azure, and then I could say deploy to Azure Functions. Before I do that though, very quickly, with that Azure Toolkit in IntelliJ, we have this little tool window called Azure Explorer. And if I click on that and bring that up, if I click on any of these items, I can then look at what I have in Azure. So if I have 10 functions, and I shouldn't have any. I don't think I've deployed any to this particular subscription. So I might have, say, 10 Azure subscriptions. If you're in a large corporation, you can actually see them all here. In this case, for demos, I only have one. Instead of the production stuff. And then any containers, Docker hosts, caches, web apps, SQL storage, like all kind of great stuff in here. All right, so you can actually manage a lot of this from here. Again, because this is a demo for me, I generally keep this empty and then deploy and then delete it after the talk. So what I could do if I want to deploy to that, again, I'll just right click and go to the very bottom here of the menu and go to Azure and deploy to Azure Functions. And then what I could do is start to give it a name and figure out what I want to call it and what I want to do. Now to deploy to Azure, I'll tell it I want to create a new function. And then first, which one of those subscriptions, right? So I have my Visual Studio subscription here. And then a name. Now this name is also going to be the name of the endpoint at the final destination. So it would be my-Azure function- and that big number .azurewebsites.net, as you see here. So maybe what I want to do is just change this, they add on all those numbers just so that you don't clash with another name because it's an actual website. So here, my Azure function at azurewebsites.net. You can pick Windows, Linux, whatever. And then all of your items, no matter what it is, needs to go in a resource group. And the resource group is just a virtual way to group assets. So it's just your organization, right? That's all that it is. It doesn't have anything other than grouping logically how you like to work with things. That is it. It doesn't cost you anymore. It doesn't do any weird stuff. The service plan, though, that's what's going to cost. And I'll just call this my service CRVIC plan. And you have these different pricing tiers. You can easily look up the pricing tiers if you go to the Azure website. But generally for functions, you're going to want this consumption. So that means you only get charged when the function is running and not when it is sitting idle or stopped. So only when it's running. And I think I want to grab something kind of close by. Oh, here we are in Germany. I'll click OK. And you can also enable application insights. That is just fancy logging. I'll just say no for now, so it takes a few less seconds. And then I think I'm ready to go. I will click OK. And it might take a minute or two, or 3 or 4. As you know, once I'm pushing something to the cloud for the first time, it has to log on as me, and then it has to go and create all of these assets and everything else. So good times sitting around waiting for a minute or two. It's generally not too long unless you have many, many functions and they're all pretty big. Okay, so as you can see, it has deployed, and here it gives us a little bit of output in the tool window about where it was deployed. So if I click this link, it should launch my browser and it should go right to that function. And here it does show me that my Functions app is up and running. So that's really good. Okay, so if I take this endpoint and I add, or this app deployment point, and add /API
/http trigger-java, which was just that default naming that it gave me. And you could rename all of that. And then add on a query string, name equal JetBrains, and I press enter. I should be able to see here. Yes, it does do that same processing, right? So it runs, it works, and things are good. So I've deployed it to the cloud. One thing I'll quickly show also is the Azure portal. So I have deployed it, and I've deployed it into Azure, and when you have an account, you can log into the portal and you will see things such as service plans, functions, storage accounts, various assets for various different things. And you will see your functions in here. So if I see my function, and there's a whole different way, many ways to manage the views. You can look at just functions or just queues or just this thing or that thing. So I could come in here and look at my function, and it takes me to an overview, and it tells me all of the stuff that I just chose while I was doing that deployment out of IntelliJ. I can also, if I need to share this location of deployment with others, I can grab a publish profile, which is a little file that gives me that information. It's great for FTP deployment. Also, you get your activities, diagnoses, security, all kind of cool stuff. Here in the functions section, I can actually click on functions, and I will see, in this case, one function, my HTTP trigger in Java. And here I could go in here and look at it a little bit just by clicking on it. So if I had multiple functions set up, and perhaps I've chained them together, so one writes to a queue, the next one reads from the queue and then puts out to a table, and then the other one reads from that table and outputs it somewhere else with those bindings, you could see them and manage them all in here. But in this case here, I go into this one function I have, and I could go into code plus test, and I can get a nice little visual of those bindings. I will see inputs, I will see outputs, and everything in between, right? So in here, I'm just going to see the function JSON, but I can also go to integration and see all that good stuff too, as well as keys and security. So a lot of good stuff in here. Now, I mentioned before you can actually write the code here in the portal, not with Java, but with .NET, which is its native thing, right? This is a Microsoft portal. At some point, I suspect, sure, we'll be able to do it with Java. So here it's read-only mode, so I could just look at what I just pushed into the cloud. But it's really great that I am able to just come in here and work with this function or any of the functions associated with this Azure Function app. All kind of good stuff, from troubleshooting to alerts and logs and all the administrative things that the cloud gives you. So you also get that. So you can use your tools like IntelliJ, but also the portal. And you do have a connection between the two. And that's really all the time I have, but this should give you a good idea of what you can use Azure Functions for, and a quick little getting started to building some awesome Azure Function apps. So thank you, and I'll be around for questions.
Hi. Okay, I know you have a tight deadline, so since nobody asked a question, I will ask you a question, which I'm highly interested in. Do you think this serverless computing trend is here to stay, or would you go and develop an application directly with Azure Functions or chaining Azure Functions, or what are the advantages and disadvantages to this approach?
Yeah, I think it will, if for no other reason. We often think of the big companies out there, like BMW and Siemens and all that good stuff. But don't forget there are how many millions of smaller companies that don't even have IT departments, or just have a single person as their programmer. Or I remember actually laughing and going, I am the IT department at certain places I work. So they are going to benefit from this even more than a fully staffed giant megacorp with an IT department and DevOps people and sysadmins and this and all these specialized roles. So this person can be somebody who writes code, maybe gets into DevOps a little, and then they could just say, oh, here we go. We have the cloud. Somebody else takes care of all of that for me. I don't have to worry about security and patching and all that stuff that a sysadmin would do. But I could write some code that maybe connects the CRM system that we got, maybe from PeopleSoft or Microsoft or Salesforce, whatever, and connect that data to this little database that I made myself. And then that spits out some reports or gets some files in Excel format to, the accounting department, which is only 2 people anyway, right? And then they can look at that in Excel and print their reports and do their work. So that's a huge market right there.
Yes.
And they're going to really, really need this. Not that big companies can't, right? Because they're taking advantage of this too, often in the same way. Because big companies are sometimes made up of little companies, even if they're technically the same company. So those kind of things are very helpful. But not just that. You do have all your assets in a central location. Everything is centrally billed. And of course, then again, you don't have to deal with that or have that liability yourself, right? Because that's pushed off onto the cloud provider. And Azure Functions, at least you could take what language you know of several languages, write with that, and then just stick it in the cloud, and there you go, right? You can even integrate it with GitHub and whatnot. So that works out quite nice.
Okay, thank you very much. I don't know when you have to go. You have to tell me, if you want to go right now, that's okay. But in any case, we have 2 more questions from our viewers. So
I'll hurry up and grab the questions and then sneak out.
Okay, in the case of Java, Azure Functions, what about performance and especially startup time of the JVM is one question from Pierre.
So it should not be terrible. I can't say I've actually benchmarked it, but I know if the function was sitting there idling, there might, depending on what resources it's accessing, like Cosmos DB or a database or something, if it has a cold start, there might be a little bit more of a startup time. I would guess that there would be, but I can't give you any numbers because I hadn't actually measured that. Like on .NET, they have a lot of numbers for that. I would imagine it's just more, and the info is probably out there.
So maybe they're using hot or pre-started JVM, so it's
they may be doing stuff like that too. Yeah.
Okay. So thank you very much, Rachel. We get another question, but I can answer this question myself. Like the high costs from the IT departments and companies for the small companies you mentioned.
Right.
I think it's not an issue. I have one client who has a school, a video school on the internet, and he's got 100,000 of AWS Lambda functions, and his bill is $400 per month. So
it's really inexpensive.
And normally his infrastructure he's running would cost thousands and thousands of euros per month. And this is,
being that if since your function, you're only billed, if you pick consumption plan, you're only billed when it runs. Then unless your code is terribly crappy with all kind of loops and doing things to tie up resources and slow, then it should be quite less expensive.
Yeah, I think so. Okay, Rachel, thank you very much for being my guest. It was a pleasure talking to you, and see you next time. Thanks.
Bye.